cover up four more questions. Okay, so let's look at question 20, part A. Okay, we want to figure out how can we actually integrate a function like that, okay, based on what we already know at the moment. Okay, clearly, based on what we know at the moment, it seems like it is an impossible task, right? Okay, but are there any suggestions?
Yes. Factorize the bottom cancel.
Factorize the bottom, okay. So simplify, factorize, okay. Maybe let's try to do that. So this one at the bottom is factorized to be what? X plus 1 square. X plus 1 square. But
That's the wrong one.
doesn't seem to help at all, right? Sorry, Noel. Integration of x squared over the denominator, then plus 2x over the denominator. Minus away the degree product. X squared plus 2x minus what? Okay, so yes, you're saying, Ryan?
Bring it up.
Bring it up.
Bring it up so that you can count negative.
Bring what up?
The
Oh,
bottom.
okay. Bring up. And we have no product rule or whatsoever.
Yeah.
So at this part also it seems like it's not meaningful.
Wow.
How?
So actually you can skip.
Don't skip the bottom.
Okay, I'm just writing out all the options that you're going to explore, that you're currently thinking about.
So is the actual answer very close to our answer?
No. Okay, so it's another option that you're thinking of.
We do like a quotient like that.
Quotient rule, there's no quotient rule. Yeah. We don't have a product rule, we don't have a quotient rule. Okay? My hint to you is that we will need to make use of chapter 3 in our A Maths. What is chapter 3 in our A Maths? Partial fractions.
Polynomials.
Polynomials, partial fractions. What did we learn?
A over something plus B over something plus C over something.
That is a polynomial, okay. How about we focus on partial fraction? What is partial fraction? What do we need to do if I need to do this in partial fraction?
We simplify the bottom.
Simplify the bottom. Okay, if you want to factorize, simplify the bottom. But is this right? To actually be doing partial fraction like that already? How should we do division? Why do you need to do division?
Because mixed fraction.
Why do I need to do long division?
Because
It's the same degree.
Okay. Because the top and the bottom has the same degree of the polynomial. Do you remember that? Okay, so we need to do our long division. Okay. So in this case, this will be 1x squared plus 2x plus 1 minus 1. Right. Okay, so long division, this one is fairly easy, just a one-step thing. So we will be able to see that it will be equals to 1 minus 1 over x squared plus 2x plus 1, which in other words is x plus 1 bracket square, okay, 1 over x plus 1 bracket square. Okay, then at this point, if I'm now going to be integrating instead of this function, I'm integrating this. Do we know how to integrate this?
Yeah.
Okay, we know how to integrate this, right? So let me just write this as x plus 1 to the power of negative 2. So then we will get x plus 1 over x plus 1 plus. Okay. Earlier on, the things things that you have mentioned, the possibilities that you threw, they are legit possible possibilities, just that it didn't really help in solving this question. Okay? I would definitely recommend that you always think about factorizing first before you explore looking at partial fractions, because it is not always all the time whereby partial fractions should be used. Okay, so do try to see if it could be simplified by using factorization first. How did I get this? Then you take this one, then after that plus this over this, the remainder over this is your partial fraction. Okay. Then now looking at part B, okay, what should we do? We should do long division. Okay, so in this case, could we actually factorize this in any way?
3x minus
Okay, the denominator, it does give us 3x minus 2 square, but it doesn't really help in solving the question, in letting us to proceed further in the integration. So let's do the partial fraction. Any questions regarding this integration? Huh? To bring down the power in the street. Yeah, sorry. This is nice. Okay. How did the 3x minus 2 square come in the denominator? Then this one is at least the same. I skipped the step lah. Okay, because I lack of space, so I wanted to cram everything inside. So that one you can buy. This is not a commodity that I can understand. Wait, minus 1 third. Huh? 1/3 is the quotient, right? So quotient, then after that minus away remainder over the denominator, right? The divisor.
Middle over.
Yeah, over the denominator. I think it's time for you to recap on your partial fractions. Okay, partial fractions is very commonly used in integration.
Great.
Although they will usually state like part A asks you to do partial fraction first, then after that part B asks you to integrate. Okay, usually that will be how a partial fraction question will be asked. Okay, it will not be as straightforward as last time, whereby it's just kept to a partial fraction question. Right? Any questions? Okay. We look at part C, whereby we want to integrate the product of 3a squared with square root x plus cube root of x. Okay, whereby a is a constant. How do we go about integrating this then? I doubt we will be needing to use our partial fraction. Okay, because there's no fraction in this case. So what should we do? Expand. Okay. Simplify. Okay, so we rewrite it into index form. Then we will just be able to do our integration as per usual. Okay, so this is nothing special. Alright, just that they introduce a, alright, which is actually a constant. You need to keep in mind that a is a constant, not a variable. Okay, so don't confuse yourself. Okay, is there any other way to do part C? Any other recommendations? Are you all okay? You all know what's happening? Is your brain disintegrating? Okay, another way that you could actually consider this function itself, we did learn that, okay, if I want to integrate a times x to the power of n, okay, whereby a is a constant, we could bring out the scalar factor out and just focus on integrating the x function only, right? Okay, so in this case, we recognize that 3a squared is a constant itself. So therefore, what we could do is to take out 3a squared and just focus on integrating this. The integration is no different. answer in this manner, or otherwise you could actually expand it, it's also fine. The answer is the same as well, but definitely the value of C in both cases will actually mean the same. It would mean a different thing. Okay, this C itself would maybe be a certain number. Okay, whereas this C, you have to multiply the 3a square to make this to be equivalent. Right? Any questions?
Explain that then the C will convert.
You can keep it to 3a square C. Yeah. Or else you can change it to a D is also fine. Right? But please definitely do not use E. Why should we not use E?
E is the
Exponential. Okay, do not use E. Question 21, the last one for this unit. Okay. First, the question asks you to actually differentiate the function given. Then after in part 2, they want you to integrate. So most likely, you will need to make use of part 1's answer to actually solve part 2. Okay. So part 1 differentiating. This one is something that you're familiar with by now, I hope. So. Up to this extent, okay, you might not be able to help yourself in part 2. Why is that so? Why is it that if you differentiate and leave your answer in this extent, you will not be able to help yourself in part 2 in knowing what to do in part 2? Why? The reason is because you will not be able to identify any similarities, okay? Clearly, the function that you have in part 2 it is drastically different from the way you have written in part 1 itself. Okay, but at this point, I hope that you know that if the question is phrased like that, asking you to differentiate and then hence integrating, you will most likely need to make use of the idea that part 1, okay, your form and after you differentiate must be similar to what you're getting in the integrating function, such that you will be able to know that it will be the reverse. Okay, this original function itself, right? Okay, we have done a few questions like that. So that's why, okay, I always encourage you to factorize as much as possible to keep your answers as simplified as possible. Okay, so therefore in this case, it will be more helpful if you were to factorize out 2t plus 1 to the power of half. Then you will be able to see that it is actually equals to 2t times square root of 2t plus 1. Okay, then you can now clearly see that there is a link between part 2 and part 1's answer. Right? Although the question, I did not write it here, okay, in the question in the textbook, right, it will say that hence or otherwise, but definitely you have no or otherwise methods of solving in the first place. Okay, so it's not possible for you to do by otherwise method. after that in part 2, how will we be able to integrate this function then? Okay, what should we do? This is equivalent to what? Sorry? Take out the t. Can we take out the t? Why can we not take out the t?
T is the x.
T is the variable. We cannot take out the t. Okay?
You put the 2 there and then you put a half outside.
Okay, good. So we put a half outside and then we put a 2 inside. Okay, such that the function left inside the integral, okay, is actually, oh sorry, no. Sorry, so integrating this will get you back to the original equation, right? Okay, so therefore, we know that if I integrate this, I will be able to get the original. Make sure you remember the plus c, okay, because that is a common downfall. You could leave your answer as such, or otherwise you could expand it. It is also fine. Okay, you can re-express it into d, or else you put half c is also okay. Any questions? Homework for exercise 18.1, question 12, 13, 14 and 18. Okay, due by today is Wednesday, due by Monday. Is that possible? Friday I'm not going to be in, so I will not be able to collect the homework. So your PRWC is due on Monday. Okay, this homework due on Monday, is that okay? Sure, Shijie, you look like you're gonna die. Can I'm not coercing you all. Okay, there is no coercion over here, alright? It is always a free market, okay, for you to negotiate. But of course, don't tell me next year lah. Yes. Sorry? Huh? Is it short now? I don't remember. Okay, so 18.1 we are done. Let's move on to 18.2. Okay, so previously we have been looking at indefinite integral. Why is it called indefinite? It is because of the kind of variation, okay, the different functions that could be resulted due to the plus c. Okay, because depending on the constant, we are going to be able to get different constants. Whereas definite integral, there is a fixed answer to it. Okay, and in definite integral, there is a different way of writing. Okay, so we write a definite integral in this manner. Okay, whereby we're looking at certain boundaries. Okay, where we're looking at integration. Okay, one of the applications for doing this is that when we look at integration, we're actually looking at the area under the graph. Okay, that is one of the applications. So like how differentiation will give you the gradient, okay, integration gives you the area under the graph. Right? So area under the graph, in that sense, we will want to have certain boundaries. Okay, we are looking at the area between maybe x equals to 1 to maybe x equals to 5. Okay, so that we have this fixed area. Because if we do not define it, then it is going to be a whole undeterminable value, right? Okay. So therefore, we have a lower boundary and upper boundary that is written as a and b. And then after that, the function fx that you're trying to integrate, so for the graph that you have. And then after that, in doing the integration, it is as per usual. Okay, just that when you're doing your calculation, there must be a final value, right? Okay, so the result will be FB minus FA, whereby what is the difference between the small letter f and the big letter f? Okay,
What is function?
okay, it is the big letter f is the original function. Okay, so when you differentiate the original function, you are going to get the small letter f. Okay, you understand? Right, so that is how some textbooks actually formally write it. Okay, so there is that difference. Right? That is just a way of writing also by using the fundamental theorem of calculus. Okay. Okay, of course we also know that big fx, if I were to differentiate big fx, we would think of having the prime. Okay, but mathematicians, they don't want to write down big F and then after a prime, so they simplify it into writing a small letter f. Okay, so these are just some common conventions that we have. Yep. A is the lower boundary, B is the upper boundary. We just write it down. Let's just start off with some examples to understand what I'm trying to say. If I want to integrate 3x to the power negative 2/3 between 1 and 8, okay, my integration method is still the same. Right? So what I will do is that I'm going to get 3x to the power negative 2/3 plus 1, that is 1/3 over 1/3, right? This is what I'll get if I were to integrate, right? Then after that, in an indefinite integral, we know that there is a plus c. But when it comes to a definite integral, we do not need to put the plus c. But what I need to consider is the boundaries itself. So I will use the square bracket in this case, okay, to put the lower boundary and the upper boundary on the right hand side of the brackets. It must be on the right, it cannot be on the left. Okay, so it must be written in this manner. Okay, after you integrate, the function is written over here. Make sure you place the upper and lower boundaries. Okay, then after that, you could simplify this first, so we will be getting 9x power 1/3, 8 and 1. Take note that we are strictly only using square brackets. We do not use round brackets. Okay, neither do we use curly brackets. Only square brackets should be used. Okay, then after that, what do I need to do after that? Because what I stated over here is that there is this big FB minus big FA. Okay, so what does that actually mean? It means that I need to substitute in the values of the upper and lower boundaries into the function that we have achieved. Okay, so this will be equals to 9. So always upper boundary first, then minus away lower boundary. So substitute x to be 8. Minus away, substitute x to be 1. Okay, so this is what it means by considering the original function. Okay, substitute in the x value to be b and then substitute the x value to be a. Alright, so in this case 9 times 2 minus 9. So the value in this case for this definite integral will be 9. Okay, we are not looking at the application of it as area yet, so just leave the value as 9, no units required. Are there any questions so far? Okay. Another one, if I want to integrate square root of 3x minus 5 between the boundaries of 2 and 7, okay, likewise I will integrate as per usual. Maybe for some of you, you want to change it to power of half first. think that you will get this. Then after that, not forgetting the boundaries. Calculator, okay, and then get the value of 14. For part C, alright, how should we integrate this function? Any ideas? How do we integrate this function? 4x minus 1 over square root x.
Partial fraction.
Partial fraction. Do we do partial fraction for x to the power of half? We don't usually do that, right? Huh? Bring x out. How do we bring x out? What do you mean by that? Up. So that means x to the power of negative half 4x minus 1 dx. Is that what you mean? Separate. What do you mean by separate?
4x over square root x minus 1 over square root x.
Okay. Then what? Then, yeah. Rationalize. You can, nobody's stopping you, but then doesn't seem to be necessary. Yeah. Okay, what do we do next? Cancel? Cancel what? Simplify to get what?
X.
To the half. Okay, minus away x for negative half. Do we agree?
Yeah.
Okay, then at this point, do we know how to integrate already?
Yeah.
We know, right? We have the skills, right? Okay, so therefore, here we will be getting this. You could simplify the fraction first before you do the substitution. But in this case, please be very careful. You're substituting the value of 4 inside the entire part first. Okay, make sure you have outer brackets, okay, to minus away the lower boundary substitution. Okay, because if you don't put in your brackets, okay, then you might cause yourself to have some error, especially when it's a minus, okay, then your operations will be affected. So, pressing the entire thing in the calculator, you'll get 16 and 2. Any questions? If not, I think you all need to practice. Will you do exercise 18.2? Question 1A, B, F, 2B, 4A, C. Okay, I tell you what, you will do until 1A. Two till 4C. I still got one more 5C. Okay, can I do this now? Alright, you need to practice that. Anyway, you all look very dead. This might re-energize your brain for the later part of the day.
So I woke up at 6 a.m.